columnar. Yesterday I told you about squamous epithelium. Simple squamous epithelium. Squamous means flattened. Flattened means the cells are very thin. All the cells are lying on the basement membrane, just like this. Very thin cells are present. See, all the cells are taking the support of basement membrane. Yesterday I told you what is basal lamina, reticular lamina. Now, in these flattened cells, we can see the nucleus at the middle, at the center of each cell. How simply the cells are arranged here. And what is the shape of that cell? Flat, just like tile. That's why we call that squamous epithelium as pavement epithelium also. Pavement epithelium or tessellated epithelium. Tessellated epithelium means why we call that as the pavement epithelium. These cells are very similar to the flat tiles on the pavement. On the sides of the street, pavements will be there. So they will lay some tiles on that pavement. That's why, depending upon that similarity, we call this squamous epithelium as pavement epithelium. What is the importance of this pavement epithelium? This squamous simple epithelium will form thin layers in the body. Why the thin layers are necessary? To allow the movement of, it may be gases or different molecules. So if you take alveolus, that is a unit of lung. This alveolus, if it is carrying oxygen, definitely blood supply is there. Here the blood vessel will be here. If the blood is moving here, this oxygen must diffuse for the movement of oxygen into the blood. At the same time, for the movement of CO2 from the blood into alveolus, this layer must be very, very thin. If it is very thick, it is difficult for the movement of gases. That's why the lining of alveolus, at the same time, Bowman's capsule, you heard about the Bowman's capsule present in the nephron, which is the unit of kidney. So here, glomerulus will be here, glomerulus. So from this glomerulus, the unnecessary substances, the metabolic waste will start moving into the capsular cavity. Like this, ultrafiltration takes place. Urine formation will take place. So for this movement of unnecessary substances, it may be uric acid, urea, or ammonia, or excess of water, or different salts. That movement of substances into this region, this membrane must be very, very thin. So here the Bowman's capsule is also made of squamous epithelium. So what are the two important functions for this squamous epithelium? One is diffusion, another one is filtration. So one is filtration, another one is diffusion. So up to here, I explained yesterday. Now let us see the second type, simple cuboidal epithelium. This simple cuboidal epithelium is just like the squamous. These cells are present on the basement membrane, but here the structure of each cell will be cube shape, like this. See, what is the difference between squamous and cuboidal? Squamous is very thin, flattened cells. Cuboidal is a little bit broader than squamous. So here also, the nucleus is present at the center, like this. So this type of simple cuboidal, you can see the ovaries, PCT, DCT. What about PCT, DCT? Proximal convoluted tubule. distal convoluted tubule. These two are the regions of nephron. So in the same nephron, different regions are having different types of tissues. The head-like bonus capsule is having squamous. The next highly convoluted area of that tubular part, that is proximal convoluted tubule and distal convoluted tubule, these two are carrying or made of cuboidal epithelium. So the main functions are secretion, and diffusion. Here, one point I want to tell you. In the ovaries, the lining of ovaries are also made of cuboidal, simple. There, we call the cuboidal cells as germinal epithelial cells. Germinal epithelial cells. So these simple cuboidal will become germinal epithelium, and that cells will develop into eggs or gametes. That's why we call them as germinal, which develops into gametes. So that is also very important. Now come to columnar. Columnar, that cells are also present on the basement membrane, but here the cells are cylindrical, like this. You can see the difference very clearly. The first type, squamous epithelium, flattened cells. The second type, cuboidal epithelium, cube-shaped cells. And columnar epithelium, cylindrical cells. Here, the difference is presence of nucleus. The location of nucleus is at the base of that cells, not at the center. So these nuclei will be like that. So the nuclei are present at the base, towards the basement membrane. So this is one type of simple epithelium. Now depending upon, see, if I am showing this tissue, group of cells, these group of cells are having free surface. The topmost surface is very free. The bottom surface is attached to the basement membrane. That's why we call this end as apical end, or that surface as apical surface. Apex means tip, top. So that's why if this apex or apical surface of the cells have cilia, now you are saying without cilia, now I will show cilia. Cilia andre, you know, very short hair-like structures. Now this became ciliated. Previous to that cilia, non-ciliated. That's why, depending upon the presence or absence of cilia, we divide the columnar into non-ciliated and ciliated. So what is the name of that first type? Simple non-ciliated columnar epithelium, simple ciliated columnar epithelium. So the main difference is, in one type cilia are absent, other type cilia are present. So that is the difference. Now you can imagine, if cilia are present, what will be the function? If cilia are absent, and I will tell you one more thing, in our body, there are some glands which are unicellular, means a single cell will produce some secretion product. That type of cells, unicellular glandular cells called goblet cells. Goblet cells. These goblet cells will produce mucus. They will produce mucus. Now, in our body, we can see non-ciliated columnar simple epithelium where cilia are absent, goblet cells are present. For example, in the stomach. In the stomach or intestine, stomach, the wall, stomach wall, intestinal wall, this area of alimentary canal is carrying non-ciliated epithelium. So non-ciliated what type? Columnar. Okay. So you have to remember that location. Examples. At the same time, ciliated. Do you know what is a bronchiole? Bronchioles. These bronchioles are the 5 branches of trachea. In the respiratory tract, trachea will bifurcate into 2 branches. Each branch will enter into one lung. Inside the lung, that bronchi will become so many small branches called bronchioles. In the bronchioles, ciliated columnar simple epithelium is present. What is the need? What is the importance? For example, if any dust particle enters into our body at the time of inhalation, through the dust, through the air, if microbes or dust particles enter into our respiratory tract, that microorganisms or the dust particles should not enter into alveoli. If they enter directly into the alveolus, they will disturb the exchange of gases and they will infect the lungs. That's why in the bronchioles, the movement of the cilia, which will be just like sweeping movement, all the dust particles will be thrown away. So in the middle of that ciliated, we can see goblet cells. They will produce mucus. The dust particles or the microbes which entered into the respiratory tract will be trapped by the mucus, and the mucus will be expelled out in the form of sputum. So if dust enters into our respiratory tract, we get sneezes. So through sneezing, that dust particles will be thrown away. So here ciliated, we can see bronchiole. And one more thing, you know about fallopian tubules. Fallopian tubules. In the female reproductive system, the uterus is having 2 types of duct-like structures. They are fallopian tubes. Inside the fallopian tube, you can see the diagram like this: fallopian tube, female reproductive system, and here you can see the uterus. So here, in this area, the ovum will be transported from one region to another region. So if the ovum is released here, ovulation, from here the ovum will enter into this infundibulum and it will reach this fallopian tube. The movement of female gametes will be depending upon ciliated epithelium. That's why ciliated columnar epithelium is present in the fallopian tube also. So in the bronchioles and fallopian tubes, we can see that ciliated columnar. So with this we completed simple epithelial tissue. So what are the total 4 types of cells, tissues? One is squamous, cuboidal, non-ciliated columnar, ciliated columnar. So with examples you have to remember. Right. Now the second type of epithelium is pseudostratified. Pseudostratified. You know the meaning of pseudo? False. So here, the second type is pseudostratified. Pseudostratified epithelium. In this pseudostratified, why that word pseudo? Pseudo means false. Here I will show one diagram. What type of epithelium? that is columnar. No doubt, because that is cylindrical cell. So now all the cells are present in single layer. That is simple. Now I will add some other structures. Now you see this diagram. If I ask you, cells are present in how many layers? Some people, this will give false image. The false image is, some people by saying this, they will answer 2. That is due to the position of the nucleus in 2 levels. Here, this is one row, this is another row of nucleus. Due to the difference in the position of nucleus, this appears like 2-layered membrane. But in fact, all the cells are present in single layer. How you can say that? There are 2 types of cells here. Some are smaller, some are bigger. All the cells, bigger and smaller, all the cells are contacting basement membrane. So small cells are attached to the basement membrane. The bigger cells are also attached to the basement membrane. What is the meaning? They are presenting single layer. Now I will show another diagram. Here, 2 layers of cells are present. The upper layer of cells are not contacting the basement membrane. But here all the cells are attached to basement membrane. That's why, due to that false image, what it is giving, we call it as pseudostratified. Actually, the fact is, all the cells are present in single layer, but it appears like presence of cells in 2 layers. That's why the name pseudostratified epithelium. Like columnar, this is also columnar. So pseudostratified columnar epithelium. This is not included in simple because of this image. It appears like 2 layers. Now, this is also divided into 2 types. One is ciliated and non-ciliated. Ciliated, non-ciliated. Means now whatever the diagram you are seeing, that is non-ciliated. If you show the cilia, that is ciliated. The apical surface, the free surface of the cells, the topmost surface of the cells will have cilia. That is ciliated. The function is same. Wherever the ciliated cells are present, it may be simple columnar or pseudostratified columnar. That function is to carry the substances from one area to another area. So ciliated, it is present in trachea. In the trachea. And non-ciliated, epididymis, urethra membranous, and penile urethra. So, to understand that, trachea you can understand easily. In the respiratory system, trachea, and epididymis, that is a part present in male reproductive system. Urethra, urinary bladder exits out through urethra. In the male, the urethra is very lengthy. That's why that is divided into 4 regions. Out of that 4, membranous and penile urethra, these 2 are having non-ciliated epithelium. Okay? Just after copying this, I will give you the flow chart. You have to copy that. Yes, that pseudostratified columnar epithelium you can see in bronchi also. I told you, columnar epithelium, it is present in bronchioles. Bronchioles are the branches of primary bronchi. So, epithelial tissue. Epithelial tissue. Right. So now, that epithelial tissue can be divided into two parts. One is covering and lining epithelium. Second one is glandular. In this covering and lining, we can divide that into simple pseudostratified compound. In this simple, number one is squamous, cuboidal, ciliated columnar, non-ciliated columnar. In this pseudostratified ciliated columnar, non-ciliated columnar. In this compound, again we get squamous, cuboidal columnar. So that's why simple squamous is different, compound squamous or stratified, squamous stratified. This compound is also called as stratified epithelium. These two are rarely occurring. rarely occurring type. In the retina, we can see one type of tissue. In the ducts of sweat glands, we can see one type of tissue. They are very rare. They are not present in more body parts. So these are the outline classification. If you write like this, you have to remember the examples. Squamous, which parts they are present. Cuboidal, in which parts they are present. Ciliated columnar, non-ciliated, where they are present. So up to here, you have to recall the diagram, the shape and structure of the cells, their location and functions. So like this, you have to coordinate the points. Okay, right. So this is about pseudostratified. Compound, I will explain in the next class. Thank you.
we were discussing about set, its definition, and we have also discussed few examples of sets. And also we discussed one of the terms related to sets, which is ordinal number, isn't it? So what is the definition of a set? It is a well-defined collection of objects. And what is the meaning of ordinal number? It is the number of distinct elements in a given set. So as I already told you in yesterday's class, today we are going to discuss about representation of a set. Representation of a set. So there are two methods to represent a set. One is set builder form. It is also called as tabular form. Okay. Now the second representation is roster form. Okay. So these are the two methods by which we can represent any set. Now let us try to understand what is the meaning of these two methods. In fact, how to represent a set using set builder form as well as using roster form. First, let us try to understand this first one. It is very simple. If you want to represent any set using set builder form or tabular form, we will just list out the elements in the set and which are separated by commas and enclosed by those curly brackets. Understood? I repeat it again. To represent a set in set builder form or tabular form, we will just write down the list of elements separated by commas and enclosed by these brackets. Understood? So this is how we represent a set using set builder form. Okay, just for clarity, I'll write it down in words. In this form, please copy along with me. In this form, the elements of a set are listed using commas and are enclosed by brackets. Enclosed by these two brackets. Okay. In this form, the elements of a set are listed or written using commas, are separated by commas, and are enclosed by brackets. Let me take one example. For example, I asked you to write, represent the set of all vowels. Very well-known example. Yesterday I already told you. Represent the set of all vowels using tabular form or set builder form. This is the question. So what would be the answer? Yes. Okay. Riyaz, listen. Look at this example, you will understand. Represent the set of all vowels using tabular form. I said, using this form, we will just write down the elements of the set separated by commas and enclosed by these two brackets. Let me assume set of vowels as some V equal to. If I want to represent set of vowels using tabular form, what are the vowels? A, E, I, O, U. I will write down the elements separated by commas and enclosed by brackets. This is like normal way of representation. That is called as tabular form. You understood now? Yes, it's very simple, nothing. If you represent the set of elements, in a normal way, like commas and enclosed by brackets, that is called as set builder form, right? Let me take one more example so that it will be more clear. Second one, represent set of all roots of x square minus 4 equal to 0 using the tabular form. This is the question, right? Now, again, answer. I am telling, I want to represent the set of all solutions of this equation using the tabular form. First of all, how many solutions you will get for this equation? 2. Because it is a quadratic equation, right? So, x square minus 4 equal to 0. First, evaluate the roots of this equation. What will be the roots of this equation? X square equal to 4. That implies x equal to plus or minus 2. Now, I want to represent these roots using a tabular form. So, if I assume that set as R, set R represent R contains all the roots of this equation x square minus 4 equals to 0. So, capital R will be equal to minus 2 comma 2 and enclosed by brackets. If you get 3 solutions, you would write 3 values. If you get 4 solutions, you would write 4 values. Understood my point? So this is called as tabular form or set builder form. It is nothing but just writing the elements separated by commas and enclosed by these 2 brackets. It is called as normal way actually. Normal way of representing a set. Understood? I hope you understood the meaning of tabular form and set builder form. First copy this, and after the completion of roster form, we will try to solve more number of questions. Okay. Wait, I'll check. Okay, fine. Small change. Tabular form is known as roster form actually. Yeah, this is correct. Second one is set builder. Right? Just change the names. Tabular form is also called as roster form. And second one is set builder. Okay. These two are not same. These two are same. So in roster form or tabular form, the elements of a set are written by using commas and enclosed by brackets. Okay. So I hope you have corrected this. Okay. Thanks for raising the doubt. Roster form or tabular form, both are same. Second one is set builder form. Right? Now let us try to understand set builder form. So the difference between these two forms is in this form, all the elements of a set will satisfy one common property where no other element outside the set will satisfy that property. I'll write it here. in this representation, the elements, please write it down, the elements of the set satisfies a common property where no element outside the set satisfy the property. Okay. The meaning of this one is, here we don't list out the elements. In the roster form or tabular form, we listed out the elements, right? We will take the same examples as in the previous case. What is the first example? Set of all vowels in set builder form. Okay. Set of all vowels in set builder form. If I want to represent set of all vowels in set builder form, in roster form I'll just write it as A, E, I, O, U and enclosed by brackets. But here I am telling all the elements of the set will satisfy a common property where no element outside the set satisfies that property. That means in this form, if I want to represent set of vowels using set builder form, I'll write it like this. Let me assume it as again B. It will be written as set of all. It will be written like this. X. X is some number, okay, some element. And here I'll use this such that symbol, okay. I already told you yesterday. X such that. Now I am assuming this vowels as X. Okay, X must satisfy the property of vowels. You understand my point? That's what I was trying to tell you. In this representation, the elements of the set satisfies a common property. Okay, so this will be equal to set of X such that X is a vowel. So this is the set builder form. You understand my point? I am taking V as set of all X such that X is a vowel. So what is the common property here? X is a vowel. Understood? So every element of this set satisfies this property. So when I take B, for example, B does not belong to V because B, X cannot be taken as B, right? Because X is a vowel. So here the underlying property is X is a vowel, but B is not a vowel. So B does not belong to capital B. Understood? In fact, that is X cannot be taken as B because every element or no element outside the set satisfies the property. So if you take any element which is not a vowel, definitely it will not satisfy this property. Understood? So all the elements of the set will satisfy a common property. What is the common property here? X is a vowel. Understood, everyone? Now if I take second example, set of all roots of x square minus 4 equals to 0 in set builder form. So what will be the answer again? Here we are given the property. What is that property? X square minus 4 equals to 0, right? So every element of this set will satisfy this property. What is the property here? That is, what is the condition? X square minus 4 equals to 0. So if I want to take it as R, it will be nothing but X such that the meaning of this one is, instead of listing all the elements as in roster form or tabular form, I will take one variable or one element which represents all the elements in the set. So in the previous case I took minus 2 comma 2. So here in place of minus 2 comma 2 I am just taking one X such that roots of X is the root of x square minus 4 equal to 0. So here the property is x is the root of x square minus 4 equals to 0. Understood? So in tabular form, we will list out all the elements. But in set builder form, we don't list out the elements. We will write down this statement. We will write down this statement by which every element of that set satisfies the property. You understood this? Please make a note of this one. We are going to look at more examples. Okay. Okay, let us take more examples. So after solving these examples, if you still have any doubt, I'll clarify your doubts. Write the following sets in roster form and set builder form. Okay, there are some 4 to 5 examples. First question. Set of all natural numbers less than 7. Okay. Set of all natural numbers less than 7. Now observe. I want to write this set. In fact, represent this set in roster form and set builder form. Now first, we will write down this set in roster form. I already told you what is the roster form. You just have to list out all the elements, okay, separated by commas and enclosed by brackets. Let me take this set as some A. A is the set of natural numbers less than 7. So it is given by, can you tell me the natural numbers less than 7? 1, 2, 3, 4, 5, 6. Is it correct? These are the natural numbers which are less than 7. So this is very simple. This is roster form or tabular form. Understood? Now set builder form. You know, this set builder form is very, very important because this representation, very often they'll use it in IIT exam, JEE mains or advanced. Understand? In so many chapters, I'll tell you later. Set builder form will be used in IIT examinations very often, okay, in the examination. So, because if they want to list out some 50 elements, they can't give you 50 elements in the question paper, right? That is the reason why they'll go for this set builder form. Because in set builder form, we don't have to represent all those 50 elements. We will just Write it as some x such that x belongs to something. Understood? Now here, can you tell me, how can I write this set of natural numbers less than n using set builder form? Just take some element, n or x. I'll take n such that n belongs to n, because capital N is a natural number. Okay, n is a natural number and n is less than 6. Sorry, less than 7. You understood? Now see, every element of this set will satisfy this property, isn't it? That's what I was telling you. A represents set of, you should read this one as set of all n such that n belongs to n and n is less than n. That means this set here represents set of all natural numbers which are less than 7. Understood? I hope this is clear, this example. If you still have any doubts, you can raise your doubt quickly. Yeah, correct. You can use x or n, anything, no problem. I mean, yeah, yes, you can write it like this. X is a natural number less than 7, but I'm using more technical way. Yeah, correct. Yeah, correct. Correct. You can. Manisha, explain set builder form again. Okay, I'll explain. Manisha, observe this one. I'll first tell you the difference between these two forms. Then it will be clear. The major difference between these two forms is, in roster form, I'll list out all the elements belongs to this property. So I am writing set of all natural numbers which are less than 7. So what are the natural numbers less than 7? 1, 2, 3, 4, 5, 6. Very easy. But now in set builder form, I don't list out the elements. For example, in the exam, if he is asking you to write down the set of all natural numbers less than 50, definitely I would go for set builder form, because I have to write 1, 2, 3, 4 up to 49 if I have to use roster form. Understood? In any problem. That's why I'll take set builder form. In set builder form, I don't have to list out the elements. I'll just write down the given property. That's it. That is, I am writing A as n such that means n is taking the position of all these elements. You understand my point? N is carrying the name of these 6 natural numbers. More precisely, I can tell you like that. Okay. Set of all n such that, now what is the condition for n? N must be a natural number, because he said set of all natural numbers, and this natural number must be less than 7. And someone has asked me, can we represent it like this? Yes, we can. N such that n is a natural number less than 7. This is also correct. Instead of n, you can take x also. You can take any variable. You can take your first letter of your name also, doesn't matter. But you are defining n properly. You understand my point? So in set builder form, whatever variable you are taking here, you must define that variable here properly according to the given problem. See, here I have defined n properly. N is a natural number less than 7. Simple. This is both are correct. Both representations are same, no change. Understood? But in the exam, even if it gives you this representation, you must be able to understand. Right? So that's what I was trying to tell you. I hope this is clear. Manisha, any other questions? I'll move to the next example. Can we use comma instead of and in set builder form? Now in set builder form you cannot use comma because you are not going to install the element set. I already told you that is the major difference. Right? Okay, good. Fine. I'll move to the next example. is important. It's a representation actually. Next example, the set of all integers which are multiples of 6. The set of all integers which are multiples of 6. Answer, please send me the answer. So from this example, I am going to highlight one more definition. That's why I gave this example. X such that x belongs to integer and x is multiple of 6. Yeah, correct. That is set builder form. Form side. We shall. He gave another representation x belongs to y and x equal to 6 in that. Yeah, this is set builder form. What about roster form? I mean tabular form, first one. I mean correct. Correct. Yeah. Praveen Patil and Meghna Chaudhary. -12, -6, 0. You have written only 5 or 6 elements. Like that, you will get infinite number, right? Vishal, 6, 12, 18. What about negative integers? Yeah, 18, correct. Fine. Actually, here I just said set of all integers. There is no restriction. Okay. So first one, roster form. So let me take this one as B. What will be the answer? 0 is a multiple of 6, right? Isn't it? 6 is a multiple of 6. 12. That means you have to multiply 6 with every integer, positive integer or negative integer. Isn't it? Factors. 18. So on. How many you will get? Infinity. Set of all integers which are multiples of 6. These are all multiples of 6, right? How many elements you will get like this? Infinite. Similarly, -6, -12, like that. Can you see this? -12, -6, 0, 6, 12, 18, so on. So actually, this set is called as infinite set. Understood? So here, let me tell you two types of sets. Finite set. It's very simple. Name itself indicates infinite set. Finite means the number of elements in that set are countable. Understood? If you can count the number of elements in a given set, then it is called as finite set. I'll explain more about this one later. Finite set. Infinite set means uncountable. I hope you understand the difference between these two. So here, this set B is infinite set. Okay, but doesn't matter. I'm just giving you small information. Okay, so in roster form, I can write the set of all integers which are multiples of 6 as something like this. And in set builder form, how can I write it like this? B equal to n or x. You can write anything. X such that x is set of all integers. This is the simplest way of writing, which are multiples of 6. But more technically, we can write it like this also. I hope you understood this one. This is very simple. X such that X is the set of all integers which are multiples of 6. I can also write it like this. X such that X equal to 6 n, where n belongs to integers. Is it correct? These two are same, right? B equal to X such that X equal to 6n, where n belongs to Z. What is Z actually? Set of all integers, that is plus or minus 3, plus or minus 2, plus or minus 1, so on like that. Plus or minus 4, plus or minus 5. You know this right already. So Z is the set of all integers. And we are just taking the factors which are multiples of 6. So I just have to multiply every integer with 6. All those numbers will give me the set of all integers which are multiples of 6. I hope you understood this notation. B is the set of X such that X is the set of all integers which are multiples of 6. Actually, it represents the multiples of 6. Understood? Any doubts in this question? Please let me know. Otherwise, I'll move to another example. Mahadevi. What is it? Why not? Praveen Patel. Yes, it is compulsory. Depending on the given question. He just said set of all integers which are multiples of 6. So it is an infinite set. So I have to, of course, I cannot list out all the infinite elements, right? So I'll just write few elements and use this so on. Okay. And here, where he is just asking the multiples of 6. Multiples of 6, right? So I can take negative integers also. Minus 18. Minus 18 is also a multiple of 6. Minus 24 is also a multiple of 6. Okay. Anything else? I'll move to another question. The set of all solutions are roots. The set of all solutions of x square plus 2x minus 3 equal to 0. So I want to write this set in roster form as well as set builder form. Can you send me the answer? It's easy. The set of all solutions of x square plus 2x minus 3 equal to 0. No. Vishal, check your answer once. Yes, we can write it in set builder form. Yeah, minus 3 1 is start. Megana, Pradeep, Naveen, set of minus 3 comma 1 is start. Roots of x square plus 2x minus 3. Minus 3 comma 1, it is not 1 comma 2, neither minus 1 minus 2. Nentra, 1 comma 4 is not the root. Please check your answer once. Spandana correct. Minus 3 comma 1. Yeah, Pradeep, n such that n is a solution of. Yeah. representation is correct. Chandramouli, Vishwas Joshi, correct. Ashish, Praveen Patel, right. Roster form. So, what are the roots of this equation? X square. I can write it as 3x minus 3 equal to 0. Isn't it? X common, x plus 3 minus 1 time x plus 3 equal to 0. So, x plus 3 into x minus 1 equal to 0. So, it will be x equal to minus 3, 1. So, if I assume this one has some set C in roster form, what will be the representation of this one? It is just minus 3 comma 1. Isn't it? Now, set builder form. What about set builder form? We'll just write it like this: x such that x is the root of our solution of x square plus 2x minus 3 equal to 0. Isn't it? X such that x is the root of x square plus 2x minus 3 equals to 0. I hope it is clear to everyone. Right? Fine. Now, I'll give you one more question. Now tell me the answer. Can I erase this? Next example. The set of all natural numbers x such that 4x plus 9 less than 50. A simple inequality. The set of all natural numbers x such that 4x plus 9 less than 50. Set builder form is very easy. You just have to write down the given statement as it is. If I assume this one as d, x such that 4x plus 9 less than 50, where x belongs to n. Isn't it? X is a natural number which satisfies this property. 4x plus 9 less than 50. Set builder form is very simple, isn't it? X such that 4x plus 9 is less than 50, where x is a natural number. So this is the common property, right, for all the elements of this set. Now what about roster form or tabular form? Can somebody tell me the answer? Yeah, correct. 1 to 10. Right. Vishal. Correct. Sankhya, Meghana, Praveen Patel, Sai, Deepak, Pradeep, Ashish. Pradeep, check your answer once. Why did you include 0? Yeah, Tarun, correct. Nishant, correct. Vishwas Joshi, correct. Yeah, it is correct. Om Sai, correct. Okay, listen, if you are unable to solve this question. First, we have to solve this inequality. I already told you 4x plus 9 less than 50. Can I write it as 4x less than 50 minus 9? Correct? I am just subtracting 9 both sides. 4x less than 50 minus 9, 41. Divide both sides with 4. 41 by 4. So x less than, what is 41 by 4? 10.25. Correct? Now x is a natural number which is less than 10.25. That is the meaning of this question, right? X is a natural number which is less than 10.25. Now can you tell me all the natural numbers which are less than 10.25? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct? So in roster form, it can be written as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Understood? So any questions in solving this inequality? Please let me know. I'll explain it once again. Any questions in solving this inequality? 4x plus 10 less than 50. X is less than 10.25 and x is a natural number. Okay. So we got 1, 2, 3, 4 up to 10. Okay. Now. What if any element does not belong to this set? Yeah, it will be an empty set. I'll tell you later. Home side. Sir, please give some terms as homework. Okay, I'll give you. Digita, don't worry. Before it goes, I'll give you some problems. Okay, fine. As I said, I'll give you some questions. Please practice these questions at home. No, you cannot write it like that. Vishal, you cannot use interval in a set. If you write closed interval 1 comma, then it means that you are taking all the real numbers between 1 and 10. Okay, but we are taking only natural numbers 1 to 10. 1, 2, 3, 4, 5, 6, 7. Okay, Vishal, that's what I'll just explain it like this. Someone is asking, can we write it like this? Set closed interval 1 comma 10. No, you cannot write it like this. Right? Because, see, 1, 2, 3, 4 up to 10. This is different from closed interval 1 to 10. These two are not same. When I say interval, it means that I am taking all the real numbers between 1 and 10, including 1 as well as 10. But here I am taking only natural numbers 1, 2, 3, 4, 5 up to 10. When I write 1 to 10, I am taking the numbers between 1 and 2 also. So how many numbers will be there? Infinite. Okay. So it represents the set of all real numbers between 1 and 10, including 1 as well as 10. So this cannot be written as something like this. Okay. It is simply set 1, 2, 3, 4 up to 10. Right. Now, I'll just give you 2 examples. Please solve these 2 questions at home. If A is the set of all positive factors of 36, then represent A in roster form and set builder form. Okay, A is the set of all positive factors of 36. Now, next one, if B is equal to so on. Then represent. I have already given you roster form. Okay. Then represent set B in set builder form. Right. Third one. If C equal to -1, 2, then represent set C in set builder form. And fourth one, D equal to T E A C H E R. Then again represent set D in set builder form. So these are the 4 questions. Very simple questions. You please try these questions at home. Tomorrow we will discuss these 4 questions. And tomorrow we will discuss about types of sets. Okay, this is also important one. So today we have discussed only the representation of a set. One is roster form or tabular form, and the second one is set builder form. And we have solved few examples on these 2 representations. Okay. So tomorrow we are going to discuss about types of sets. So please solve these 4 questions. That's it for today. Thank you so much. I'll see you tomorrow. Okay, homestead. Yeah, I told you already. For such set, I can use this one or this one. Just a vertical line, not this one. Understood? This is not correct. This one or this one. Okay.